It's what it is. What it is. Okay. Let me share my screen now. Am I sharing or no? Somebody answer.
No.
Ah,
No.
I didn't think it was either. What happened? I went and did it. Maybe I stopped sharing at the same time as I was starting it. Now am I sharing?
Yeah, now you're sharing.
Okay. What I wanted there. Okay. This handout you were supposed to see looks like this. Okay. And so all that you would learned that day was to graph a basic. What happened? I thought he was in already. Is how to draw a basic sine curve and how to graph a basic cosine curve. Okay, guys. If you guys are going to come in 15 minutes late, you guys may as well wait for the video or something, because 2 people waited 15 minutes to come in, and I don't know why. It's not right. No, I'm sorry, I lied. It's not 15. You started at 10:40. Never mind. You were only 5 minutes. I take it back. You know, 5 minutes late is still, you had a 15 minutes since your last class ended. I don't know, you're home. You're sitting at home. Doesn't take that long to walk back to the computer, I don't think. The sine curve, basically, here's my shortcut method that you're going to see me do on everyone. If you do the method that's in the textbook, they do a lot of finding values. It actually gets kind of confusing. Here's my simple method. Draw 3 horizontal lines. Draw at least 2 vertical. Because you can do 1 full period between those 2 vertical lines. Now, sine curve, this has an amplitude. You learned this in the last lesson. The amplitude is this number up front. It's a 1. Then we've learned that the number in front of the x in this one is a 1. So I'm going to call that the letter B. That stands for your frequency. Frequency tells you how many pictures can you draw of this sine curve between 0 and 2 pi. And the reason I'm saying 0 is because right now we haven't learned how to shift left or right or up or down. So in your first lesson you had, the middle horizontal line was your x-axis. This was your x-axis. And your original y-axis was here at the 0. I don't know why I keep saying the same color. It was here. So basically, those are my axes. That's without shifting your curve. So sine curve starts, well, here's what I do. I take my period, no matter how big it's going to be, I cut it up into 4 pieces. Cut that in half, cut this in half, cut this in half. And here's what I'm going to do here. Sine curve starts at the origin, 0, 0. And this is a +1 amplitude. So that means when we say the absolute value of the amplitude is a 1, that means the highest it can go is a 1, and the lowest it can go is a -1. If it's a normal sine curve, no other numbers other than 1s in there, then it starts here, and here's my quick method. Goes up, comes down in the middle here, comes down to the bottom, and goes back up. So your typical sine curve, try to be a neat, smooth curve. And that's your sine curve. That's 1 period from 0 to 2 pi. How do I know this finishes in 2 pi? Because you take the frequency. The period is this tau symbol. Tau is the Greek symbol. That means period. How long will it take to graph this function? Starting from start to finish. The formula is always 2 pi, because that's how long a normal sine curve takes. 0 to 2 pi is a 2 pi distance. 2 pi divided by the b. I already told you that inside this one was a 1. B was a 1, so 2 pi over 1 is 2 pi. This equation gives you one full picture in 2 pi radians, meaning from 0 to 2 pi is one full picture. If I wanted to go do another full picture and do another period, I could go this way and cut this up into 4, realizing that it starts at the, I actually messed up on this curve. Anybody see where I messed up? Somebody has to see it. I complete ignorance. I fell on my head. Actually, I did fall on my head one time. So I'm not really lying. I want it erased, not on the eraser. Makes sense. There, okay. Nobody answered. I guess nobody got points extra. It ended here. It's supposed to end here. Okay. And so do another period. It starts here, goes up to the highest, goes back to the middle, down to the lowest, here. Smooth curve. I could do another period the other way if I wanted to. I could go this way. Again, I would cut it up into 4 equal, cut it in half, cut it in half, cut it in half. Now, since I'm going this way, I could start here and go up, down, and it ends in the same place. Or I could continue the pattern backwards and just go boom, 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 boom. See that? Now, I really want you to, for sure, to identify these 3 numbers, because those are my horizontal lines. It's better to put them out here so it stands out, not in the middle of a couple periods. And then on your x-axis, I have my start and I have my finish for one of my periods. I really need to find out what these 3 numbers are. And I'm going to show you how to do it real quick here. It gets harder though. To find the middle between any 2 numbers, you take the average of these 2. So here's the work. You take 0 plus 2 pi and you divide it by 2. That gives me a pi. So that's my middle. To get the middle between these 2, I take the 0 plus the pi and I divide that by 2. That's pi over 2. So that number is a pi over 2. 90 degrees, 180 degrees, 270 degrees, 360 degrees. So I take pi plus 2 pi, that adds up to 3 pi, divided by 2, 3 pi over 2. So you will want to start adding your numbers on your graph. If I want to continue the second period, it takes 2 pi to finish up. So 2 pi, how do I get to the next one? I take 2 pi, I add another 2 pi to it. This ends up at 4 pi. To get the middle here, 2 pi plus 4 pi is 6 pi divided by 2 is 3 pi. To get the middle from here to here, 3 pi plus 4 pi is 7 pi. 7 pi divided by 2 is 7 pi divided by 2. To get this tick mark here, 2 pi plus 3 pi is 5 pi. 5 pi divided by 2 is 5 pi divided by 2. That was the easiest they're ever going to be. They're going to usually be harder than that. I could also keep going. If at 0, that distance for the next one has to be a 2 pi distance. So 0 minus 2 pi takes me to a negative 2 pi. Actually, where did I end up at? Oh yeah, that's it. You get the middle here, negative 2 pi plus 0 is a negative 2 pi divided by 2 is a negative pi. So that number is a negative pi. You got the point here? That's the basic sign without shifting it left or right or up or down. That's today's lesson. Cosine, on the other hand, I'm going to do two periods, one this way and one this way. So again, this is my x-axis. This will be my y-axis. And since cosine has a 1, it's just a normal cosine starting at 0, ending in 2 pi, or starting at negative 2 pi, ending at 0. I do the same thing. Cut it in half. Oh, by the way, how high is it going to go? It's going to go 1. So 1 up, 1 down. I need that number. That's a 0. I did not shift it up or down. So I need that number. I need that number. So I got 1, 2, 3 numbers, 4 numbers, 5 numbers, 6 numbers. Let's do this one here. Cut it in half, cut it in half, cut it in half, and realize that it's a normal cosine. Normal cosine starts high, so starts up here. Comes down, has to go through here, has to hit the bottom, starts back up, goes here, and then it has to go to the very top. So the smooth curve, boom. Now, the title of this paper was Graphing Sines and Cosines. I'm going to call this sinusoids. They're all sinusoids. Why do I mean a sinusoid? Just for fun, here's my 0 to 2 pi, and maybe I'll even go to the 4 pi again, because, oh, why did I do 45? 4 pi. So what happens is I got this middle number, it's not shifting, so it's a 0 here again. That's a 1, that's a negative 1. Sine starts at 0. Let me do my 4. If I don't do the tick marks, I mess it all up. I don't get very good dots. Sine starts at the 0 here, 0, 0, goes up to this first tick mark, it goes all the way up. The next tick mark, it's in the middle. Then the next tick mark, it's at the bottom. Then it ends here. Nice, beautiful sine curve. We do another one. I'll do it a little quicker here. Starts at the bottom, goes up 1, comes back down in the middle, goes back down, and starts it. See, so it's continues this beautiful curve. Now, cosine, let me call this sine. Cosine starts at the top, comes down to the middle line at the first tick mark, middle tick mark at the very bottom, next tick mark in the middle line, then it's back up to here. I'll continue those dots. Down, down, back up, back up. And here's the picture. Notice that those two curves look the same, except for one small difference. Here's my cosine. If I take the green curve and I shift it to the right, it'll line up to the blue curve. Or if I take the blue curve and shift it left, it lines up with the green curve. Somebody thumbs up if they see that. The other period, oh, good, I got 1 thumbs up. But how did I do it in the other class? I was able to, well, I think I did this. Okay, so somebody else thumbs up again. I want to see if the symbol comes up on my computer. Oh, it's still the same thing though. I had something where I could see, I can only see like 6 people right now. So I don't always see all of you thumbs up. How did I do it? I actually had it up where I could see anybody thumbs up. It didn't show me who it was. I see Gabby thumbs up. How did I do it? I just don't know how I did it. I literally had a little counter at the bottom. It was actually counting down the number of hands up at the moment. I don't know how that happened. Anyway, those are called sinusoids because they're both actually the same curve. They're just shifted left and right. All right. So let's move on to what you were supposed to have learned besides that. This first page is nothing but identify the amplitude and periods. As you go down, we're identifying the amplitude and periods through the graphs. The next page actually has you graphing them. You did a lot of that. So those first 2 pages you should be able to get through, but I want to review with you a little bit. Sine of 4x. Why is this problem different? It's different because the A is still a 1. That means your amplitude is the absolute value of 1 is a 1. Doesn't matter if it was negative. It's still be at the same amplitude. It doesn't matter if it goes up or down. It's still the same. Now, the B number, there's a B number here. My B is a 4. That's my frequency. That tells me how many pictures I could graph within 2 pi. A normal, if I was to graph it stretched out to 0 to 2 pi, I could get 4 pictures in there. Now, this is not going to look very pretty, so just bear with me. If I cut this into my normal tick marks, every tick mark means the picture got done. So I mean, I'm going to have to draw a whole sine curve there, a whole sine curve here, whole sine curve here. I would get 4 pictures. Now I can zoom in, so I can try to do 4 pictures here. This is just to show you what it means. If this is my 0, and here I go, cut this into 4 pieces, starts here in the middle, goes up to the top, comes down to the middle, comes down to the bottom, and there it is. There's my beautiful sine curve. Again, cut them in half, starts in the middle, goes up to the top, comes down to the bottom, and goes back up here. Here goes. Continue that picture. There's 2 full sine curves. One, cut it in half, cut it in half. There you go. Start here, go up to the top here, come down to the middle here. You see, I'm lining up my tick marks. Then I come down to the bottom, and then I go here. Just that's a normal sine curve. One more. Half, half, half. Start here, go up, down to the middle, come down, go up, boom, 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 boom. There you go. Look at that. I zoomed in. For the average bear, look at that. 0 to 2 pi, there's 4 pictures in there. Why is there 4 pictures? Because your frequency is 4. Now, the question is, what's my period? My period means how long did it take to go from here to here? What's that distance from here to here? Which is, by the way, the same distance from here to here. This is my period. Okay? And so period means how long does it take to finish up one picture? Period tau is equal to 2 pi, because I have 2 pi is my normal. How many can I get in there? 4. That's pi over 2. That means from 0 plus 2 plus pi over 2 is pi over 2. Pi over 2, if you do your scratch work there, plus another pi over 2 takes me to 2 pi over 2, which is pi, which makes sense. It's the middle between 0 and 2 pi. What's in the middle between 2 pi and pi? Well, you add those up and divide by 2. Or you could just take the answer, pi, and add another pi over 2. That takes me, that's a little harder to do, put a 1 there. 2 times pi is 2 pi. 1 times pi is pi. Over their product, 3 pi over 2. I almost had that answer in my head a minute ago. 3 pi over 2. And that's 2 pi, which is the same thing as 4 pi over 2, if you want to be totally honest. 4 pi over 2 is 2 pi. So that's what's happening here. All right, let's move on. What if it's a cosine graph? I want 5 pictures in the middle of 0 and 2 pi. I'm not going to graph it, guys, because it's right now, I'd have to draw a nice grid and be very neat. I'm just going to answer these questions. My amplitude is the absolute value of 5, which is 5. Right or wrong?
Wrong.
Wrong, thank you. I'm wrong. Glad one person was awake. This is my amplitude right here. There's my amplitude. That's my B. That tells me there's 5 pictures embedded in to 0 to 2 pi. So my amplitude is absolute value of 1, which is 1. My period, my tau, is 2 pi divided by 5. That's not very big, guys. Think about what 360 divided by 5 is. That's 72 degrees. This finishes in 72 degrees. Look how many 72 degrees there are between 0 and 2 pi. There's 5 of them. So in the other picture, I had 4. This had 4 pictures. What would happen if I created 5 pictures? Wouldn't those graphs even be skinnier?
Yes.
Yes. And in real life, what does it mean to have a higher frequency? What's a real life example that involves frequency?
Faster.
Say it again.
Faster.
Faster. Is that what you said?
Yes.
Faster what?
I don't know. Circles.
How about sound waves? Sound is a wave. Sound is nothing more than waves coming at you. What if a train is coming and you hear it off in a distance? Those sound waves are really spread out. I can hardly hear it because the waves are coming at you, but it's so far away. By the time it gets to you, it's already dissipated some of the waves. But as the train's getting closer, you got more waves. The pitch gets higher. It feels louder. You almost feel it on your skin. Now when the train is really close to you, there's a lot more waves. And it's getting louder and louder. And pretty soon it is so loud that it's just almost busting your ear. But as the train leaves, guess what happens? It starts away from you. So it starts slowing down and you almost can't even hardly hear it anymore. When the frequency goes up, the pitch goes up. It seems louder. The bass can get pitchier. As it slows down, the bass gets lower and it's farther off. It doesn't hurt your ears. Okay. Here's my physics lesson for the day. Round of applause. Thank you. This is a normal sine curve. A is 1. B is 1. Amplitude is 1. Period is 2 pi because 2 pi divided by 1. We drop down to number 6. This is going to probably need a reteaching of something. I have a negative angle here, a negative angle. So let me talk about that negative angle for a minute. If I want to look at y equals the sine of a negative 30 degrees on a unit circle, well, let me first do positive 30 first. That means the angle goes up this way, and there's 30 degrees here. It opened up. If I draw my triangle, then opposite 30 is a 1. The hypotenuse is always a 2, and the other leg has to be the square root of 3. The sine of 30 degrees in quadrant 1 here is opposite over the hypotenuse or opposite over the radius, however you want to do it, will be a 1/2. If I talk about y equals sine of a negative 30 degrees, then the picture changes slightly. I'm opening down, so the angle's going that way. And that's a negative 30 degrees. But if I drop my perpendicular, it's still a right triangle. Opposite the 30 is still a 1. Hypotenuse is still a 2, and the other leg is square root of 3. But pay attention, this is going down, so it's a negative. This stays positive, didn't change. Hypotenuse never changes. So sine of a negative 30 degrees is still opposite over the radius or the hypotenuse. In this case, it's a negative 1/2. So the only difference when you put a negative there is that the answer becomes negative. So you have permission to say sine of a negative 30 degrees is identical to the negative of the sine of 30 degrees. Because of the same answer, except for the answer is negative. This makes that problem so much easier. Let me also show you something else with the sine curve. Back to my picture. Back to my quick idea of how do I graph the sine curve. If I start at 0, and here's my middle, also at 0. Watch this. If I graph my sine curve this way, picture is going to have 4 tick marks, 1, 3 in the middle there. So starts here in the middle, goes up, comes down, goes down. So I keep doing the same thing, guys. Don't make it hard. Just cut it up. That goes to 2 pi. Let me do the negative angles. If I do the negative angles, cut it in half, cut it in half, cut it in half. Now I got my starting in the middle, goes up, comes down, goes down. Same picture. Okay, so if I do 30 degrees, the answer is here. 30 degrees is roughly, let's see, this is pi. That's 180. This is 30 is going to be in here. Here's 30 degrees, roughly, right here. See the y value? The y value is positive something, positive. If I do negative 30 degrees, that's about here, negative 30 degrees. Check it out, check it out. What's the y value here? Negative. You see why? That the sine of 30 is the opposite of the sine of negative 30? It's symmetrical, but one is up here and one is down here. You see why this definition is true? Go back to that problem. What I personally would do is rewrite the problem as a negative 2 sine of 4x. Now that negative 2 does cause a problem because now the sine curve flips upside down. If you remember, if you graph y equals square root of x, that looks like this. If you graph y equals the opposite of the square root of x, that looks like that. It flips it over the x-axis. That's what multiplying a function by a negative does. It flips it. It's reflected over the x-axis. So I know that's going to cause a problem when I graph it, but let me just do the amplitude. I'm not using this one now, I'm using this one. Absolute value of a negative 2 is still a 2. It's the same amplitude. Period. 2 pi divided by the b, which is 4, is pi over 2. So much nicer than thinking of negative numbers in there. Now, what does that mean about that? I'm going to do that graph real fast here. It's a negative 2 sine of 4x. Y equals negative 2 sine of 4x. If I was just doing a simple graph, there's my middle. It did not shift up or down, so it still starts at 0. This time the amplitude is 2. Remember, absolute value of a negative 2 is 2. 0 plus 2 is 2. 0 minus 2 is still a negative 2. Cut this into 4 pieces like I always do. Boom. Sine starts in the middle. But this time, instead of going up, it goes down because it has to flip. It had to flip. The original sine does this. That's the original sine of 4x. This one flips upside down. Now, because there's a 4 in front, I had to do that period, which we said was 2 pi to pi over 2, meaning from here to where it starts, since there's no other number being added inside this function, it starts at 0 and it ends at pi over 2. Because it ends at pi over 2, how do I get these 3 tick marks? What are they? Well, to get the middle, it's very simple. To get the middle, You add the two ends. 0 plus pi over 2 is pi over 2. But then what you have to do is divide by 2 to get the average of those two numbers. When you take a fraction, divide by 2, the denominator just doubles. So this is pi over 4. Let me get these two middle numbers. How do I get between the 0 and the pi over 4? You take the 0 and you add it to the pi over 4, and you take that answer, divide by 2. That adds up to pi over 4 divided by 2 really is pi over 8. This is pi over 8. To get this tick mark here, you take the two endpoints. That's pi over 4 plus pi over 2. Take that answer, divide it by 2. How do I do this one? Very carefully. I take the 2, I multiply it by pi. That's 2 pi. That's a plus sign. I take the 4, I multiply it by pi. That's 4 pi. I take the 2 times 4, that's an 8. Divide it by 2. Oh, wait a minute. Then that's not really 8, it's a 16. So if you keep that in mind, that when you take that 8 divided by 2, it's a 16, that gives me 6 pi over 16 reduces to 3 pi over 8. So 3 pi over 8 is that last one. Check this out though. 0, add pi over 8. Add another pi over 8. Pi over 8 plus pi over 8 is 2 pi over 8, reduces to pi over 4. So if you think about it, it was 0, 1 pi over 8, then 2 pi over 8, then 3 pi over 8, then 4 pi over 8. This distance is always the same. Pi over 8, another pi over 8, another pi over 8, another pi over 8. And 4 pi over 8 is the same thing as pi over 2, which is what I had written here, see? There's a lot of ways to look at that, okay? Let's do a couple more. Let's do the sine curve. Does that change? It's the same idea. Oh, it's got a, we've done sine curve. What did I just do? Oh, I did this one here. I did -4. How about the cosine with the negative number? Back to my cheat sheet. Y equals cosine of 30 degrees versus y equals to cosine of a negative 30 degrees. What does a negative do on cosine? Unit circle. Cosine is positive 30. That goes up this way, 30 degrees. Drop a leg, right angle. That's still a 1. That's still a 2. That's still a square root of 3. Cosine of 30 degrees is adjacent over a hypotenuse. Adjacent is that leg. There's the hypotenuse. Square root of 3 over 2. If I do the cosine of a negative 30 degrees, that means the angle goes this way. And that's still going to be a 30-degree angle, but it's negative. Still a 1, still a 2, still a square root of 3, it's still there, and it's positive, still positive, but this one becomes negative. So that's equal to the adjacent over hypotenuse. Now the adjacent is, that's weird. The adjacent is still square root of 3 over 2. What did you notice?
They're both positive.
They are. So you can literally say the cosine of a negative 30 is the same as the cosine of 30. I can prove it to you with a graph. Let's do a cosine graph. Okay, cut it off here, here it goes. I'll start here. Cosine starts on top. Let me do my 4 tick. If I don't do my 4 tick marks, I'll mess up. Starts at the top, goes down, goes back up, It looks like this. That's 0, and that's 2 pi. If I go this way, and I cut it up into the 4 tick marks again, it goes, starts at the top, comes down, goes up, here it goes. Okay, so what happens? 30 degrees is about here. There's the y value. Negative 30 is about here. Y value. Notice the Y value is the same. They are the same answer. So enough of that nonsense. Amplitude. So what I'm going to do, I'm going to rewrite this problem as equals to 3 cosine of 2x. Don't worry about the negative. Look at that. Amplitude is 3. Period is 2 pi over 2, which is pi. So if I was to graph this picture, if I can graph it real quick here, and I do 2 periods, look what happens. I'm starting at 0 because I'm not adding anything inside the parentheses, so that finishes in 2 pi. Here, look what happens here. In 0 to 2 pi, it finishes in pi. That means it actually finishes in the middle, pi. So in pi, it's a cosine, so it starts here. I got to do my tick marks. If I don't do my tick marks, I always get it wrong. Start here, come down, go up. There it is. Kind of weird. I don't have enough room. But then I have another one here. Another one there. See? 2 of them. 2 of them in the pi distance. I'm sorry, it was 2 of them in 2 pi distance. I'm sorry, it's 2 pi distance. One was done in pi, another pi. I have 2 of them in 2 pi distance. 2 of them. That's what that means. All right. Enough of those for right now. You guys can play with the others, look at the graphs. Let me move on to the actual lesson for today. We are doing translations. That means we are moving left and right. I should say the word or, can't do both. And moving up or down. Same rules apply. That's the horizontal, that's the left and right. This is your vertical, that's your up and down. This gets very complicated how he worded it. Let's just see what we're doing here. F of function, x minus d. That's the same thing as saying y equals the square root of x minus 1. My function, f of x, is square root of x. F of x minus 1 means there's an x minus 1 in the square root. What does this square root do? Remember? The square root of x, this one was simply this picture here. What happened when I went minus 1 inside the function? Does it go up, down, left, or right?
Right.
It does the opposite of what you think. It's either left or right. And it does the opposite, so it's going to the right. So I have to shift 1 over. The picture looks like this. Same thing for the sine curve. If you are going d minus d, if that's a minus 1, then it's going to shift to a 1. That's where the sine curve is going to start graphing, not at 0. It's going to start at 1 if I put a 1 there. Okay, so how is this going to work here? Here's your first problem. And I realized what he wanted. He only wants 1 period. So if I start here, and I'm going to ask myself, my frequency or my amplitude is still a 1. My period, my tau, is 2 pi divided by, what number is in front of the x? Anybody? What number is there?
A 1.
A 1. So it's going to finish still in 2 pi. So I'll just cut it off right here. And the question is, does it start at 0? Or does it start at, it shifts to the right, pi over 3. It doesn't start at 0. So what I'm going to do is I'm going to take off the 0 there. I don't really need it there. This doesn't help me. It's actually starting at a positive pi over 3. 0 is over here, if you really want to be honest. 0 is over here. You can graph it any way you want. I just choose to take a vertical and a vertical, say it starts here. Then I have to go and say, well, how high will it go and how low will it go? So I look at my amplitude. This thing does not shift up or down because there's no plus or minus a number being added to this function. So it's 0, add 1, 1, take away 1, negative 1. So technically my x-axis is still here, but my y-axis is back here, but who cares? All I care about is where does it start and where is it going to finish? Now, we said that it finishes in 2 pi. I wrote somewhere there. Didn't I write it? No, I didn't. I don't know if I did write it. Yeah, I did right here. 2 pi. So how do I get where it ends? So on your paper, you need to have a spot where you're doing all your scratch work, okay? And to find the end, where it ends, I'm going to take the two, I'm going to add the 2 endpoints. I can't. That's silly. I don't have to. I misquote. That's finding something else. I want to add my period to the beginning. So pi over 3 added to how long will it take to finish? 2 pi. And how do I do that math? I put a 1 under here. They're not the same denominator. So 1 times pi is pi. 3 times 2 pi is 6 pi. So I'm adding 6 pi divided by the product of the 2 denominators, 3. That turns into 7 pi over 3. This one starts at pi over 3 and ends in 7 pi over 3. Then I realize that it's a sine curve. And if I cut this up into my 4 tick marks, it's going to start here. It's going to go up to here. It's going to go to here. It's going to come down to here. And I've done this already for you like 7 times. So goes up, come down. There's 1 period. You only wanted 1 period. Starts at pi over 3, ends at 7 pi over 3. Now you're asking, how do I get these other 3 numbers? I'm pretty happy that you give me those 2. I'll even be happier if you give me the middle. Okay? So for this problem, we're just going to get the middle. 1 middle, not all of those. How do I get the middle? To get the middle, you add the 2 endpoints, and then I divide it by 2. That's an average. So here goes. Pi over 3 plus 7 pi over 3. Take that divided by 2. Good news. Common denominator. That's 8 pi over, I want to say 3. But because I'm dividing the whole thing by 2, that 3 really becomes a what? A 6. It doubles. Now, if you want to leave it as divided by 3, divided by 2 over 1, you're welcome to do that. That means 8 pi over 3 times the reciprocal. Now you see why I just doubled it? 8 pi over 6, the same answer. That reduces to 4 pi over 3. So there's my middle. 4 pi over 3. So I'm going to call it a good problem right now. I have the lowest it'll go, I have the middle, I have the upper, I have both endpoints, and I have the middle of it. That's pretty good. That's worth, out of 10 points, that's worth 8 points. You did a good job at those, all the numbers you gave, okay? I like this question here. How does the graph of this problem differ from the graph of this problem? Notice the differences.
One's in parentheses.
Say it again.
One's in parentheses.
That one's in parentheses, meaning that this function has to move pi over 3 to the right because there's a minus there. This one, the function ends here, and there's nothing being added to the x. This is on the outside of the function. This means this function is moving down pi over 3 because you're taking the sine curve, taking a value away means you're shifting it down. That's what happens. You'll see that coming up here. Let's do another problem. I don't like the lettering he uses because I like to do this. I like to call this my A. The number in front of the X is my B, so I got a B. But then I like to call the number in here, I like to call it C, but he calls it D, and I don't know why. But anyway, let's talk about the period, the amplitude. The amplitude will be the absolute value of 3 is 3. My B is a 1. My period would be 2 pi divided by B, which is 2 pi. Then I have this plus pi over 4. And it's inside the parentheses, and there's a 1 here. So as long as there's a 1 out front, then I can just say, what does this function do? It moves to the what? Left pi over 4. Because there's a plus pi over 4 means left pi over 4. So he wants one period again. So let's see. It shifted. So let me cut it off here. And I'm going to use this as my starting. And then I'm going to draw my horizontal and my horizontal. Does this shift up or down? Did you hear me say anything about shifting up or down?
No.
And I'm going to put a 0 here. And the amplitude was a 3. So 0 plus 3 is 3. 0 minus 3 is a negative 3. So here are 3 important horizontals you need to have. And then my starting place, let's see. It doesn't start at 0. It has, the 0 would have been here. But I'm shifting it to the left pi over 4. So it's not really a 0. It's 0 minus pi over 4, negative pi over 4 is where it starts. And where does it end? It ends, remember the secret? You take where it starts, negative pi over 4, and you add the period. How long will it take to finish? 2 pi. So I got to take the negative pi over 4 and add it to 2 pi over 1. Very simple. 1 times negative pi is negative pi. 4 times 2 pi is 8 pi. 4 times 1 is 4. Negative 8 pi plus 8 pi is 7 pi over 4. That number is 7 pi over 4. All right, the middle. Since I got to do all my numbers, let's just do all the numbers right now. Let's do the middle right now. How do I get the middle? To get the middle, you take the 2 endpoints. One was a negative pi over 4. The other is a 7 pi over 4. And I'm dividing it by 2. That's how you get a midpoint. This is how I got the end point. Okay, last period, I was really dumb. I didn't notice that the denominators were the same. So it caused me to do extra work. Since I see the denominators are the same, negative 1 plus 7 is simply 6 pi over 4. But I'm dividing it by 2, so it really becomes a 6 pi over 8. Reduce that, 3 pi over 4. So that's the midpoint. 3 pi over 4. Let's go ahead and do this middle right here. Let's do this one. How do I do the midpoint? I take the 2 ends, add them together, and divide by 2. So that's a negative pi over 4 plus 3 pi over 4. Divide that by 2. That turns into, hey, same denominator. Negative 1 plus 3 is 2 pi, not over 4, but over 8. You see what I did? It would have been a 4, or if you wanted to do it harder, you could have multiplied it out to get the 16 or something, but that reduces to a pi over 4. That number becomes a pi over 4. To get the last middle number, I take my input. So you need scratch paper somewhere or a clean sheet where you're keeping track. Let's see here. I'm gonna do it over here. That number was 3 pi over 4. I'm going to add it to the 7 pi over 4. Take that answer, divide by 2. Same denominator. 7 plus 3 is 10. That's 10 pi over 4 divided by 2, 10 pi over 8, which is 5 pi over 4. 5 pi over 4. Now, let's look at the picture. I know it's a cosine, so cosine has to start up. Then on this x value, it's touching the middle. Then this x value, it's down here. Then this x value, it's going to be coming back up. And on this x value, it's up here. So it's a curve. And I'm not very good, but close enough. That's one period. That's a pretty good period, I would say. Let's do another one here. Now he wants 2 periods. Okay. This time, there's one thing, there's a catch. Yes, my b is 3. It is true. But I can't leave it there, guys. You cannot leave the period, not the period, the frequency. You can't leave it in the parentheses. So I have to factor it out. So I'm going to rewrite this problem as y equals negative 2 cosine. Pull out the 3. When you pull out the 3, 3x divided by 3 is x, plus pi divided by 3 is pi over 3. You have to rewrite it. Now, if you want to put another parenthesis in, feel free. It's okay. The book does that. All right, let's see what we got. We got our amplitude is the absolute value of a negative 2, which is 2. Since it's negative, you know it's going to be an upside down cosine, so keep that in mind. My b is a 3. Therefore, my period is 2 pi divided by 3. That means I get 3 pictures in 2 pi distance. I'm dividing it all up into 360 divided by 3 is actually 120 degrees. So every 120 degrees is a new picture. What else do I need to know? It shifts, look at this one right here, shifts left or right. It's a plus sign here, shifts left, pi over 3. That means it's negative pi over 3 because normally it starts at 0. Okay? So what I'm going to do is I'm going to do this. I'm going to call this negative pi over 3 starting out. Okay? And I'm going to make my horizontal lines. And since it's a negative 2, and it did not shift up or down, there's no plus or minus a number here. So I'm going to call that 0. And then my amplitude is a 2. I have it written right there. 0 plus 2 is 2. 0 minus 2 is a negative 2. And he wants 2 periods. It looks to me like he's actually wanting a period to the left and a period to the right. It doesn't really matter. You want to go with 2 periods this way, do it. But if you don't, you want to do, the book may go 1 period to the right and 1 period to the left. That's fine too. That's still 2 periods, okay? There's a reason why one might be better than the other, but it's not important enough to bore you. All right, it's a cosine, so I'm going to have 4 tick marks. 1, boom, boom, 1, boom, boom. And it's going to look like this. I'm just going to draw the picture first, then I'll worry about my numbers. Upside down cosine means it doesn't start on top, it starts at the bottom. Goes up to the next tick mark, going up, goes up all the way, comes down, boom. Keep going, up, up, down, down. So the curve basically is looking like, that's pretty good. And I'm not even an artist. Look at that. Up. I'll finish this up in a separate video so you can finish it up to do a couple of My Math Lab problems. Other than that, take it easy.
Bye, sir. Have a nice day.
Bye, sir.
You too. Joseph, bye.